I'll give you about 45 seconds to a minute to get that finished up. Alright, so get those glued in. Share glue sticks. Once you have this glued in, if you glued all of them in, you can go ahead and put the glue sticks and the scissors and stickers, not stickers, glue and scissors. Oh. Damn. No. I do not know Max. Do you know Max? Alright, about 30 more seconds. A couple slow gluers here. My last class we glued and then we worked and then we glued and then we worked and that just took forever. So hopefully we go a little bit faster now that we did all of our gluing. Alright, I'm going to be using 2 highlighters as we go today. I'm going to use pink and yellow. If 2 highlighters you can, or if you want to use colored pencils. I might actually use colored pencils. I like colored pencils better, but I didn't. It was a lot when we were cutting and gluing and cutting and gluing. So now that it's all glued, we're just going to use colored pencils. So 1, 2, 3, 4 on one side, 5 and 6 on the other. Alright, here we go. So we are more inscribed angles. If you need help getting those glued in, Miss Sawyer maybe can run over and help you. Okay, 10-4, inscribed angles. Inscribed kind of sounds like what word? What? No, I was just letting them know that they could ask you. That's always an option. Inscribed kind of sounds like inside. Crazy, right? It doesn't? Inscribed inside? Okay. In my brain, they sound the same. Alright, anyways. It's an angle where the vertex is on the outside of the circle.
Can you zoom in a little bit?
I can. Just be a little bit more centered. An angle with a vertex on the circle. And sides that are chords. So in this picture here, what is the inscribed angle? Remember, how many letters do we use to name an angle? 3. Q, R, S. It's at angle R, but there's just a lot going on at R, so we have to name those 3 letters. So Q, R, S.
Or you might have said SRQ, that's fine. That means that R is in the middle.
Okay, so QRS is the inscribed angle. What's the arc that kind of closes out the angle? It would go from Q to S. Okay, so arc QS, we call that the intercepted arc. Because it's getting intercepted by an inscribed angle. I don't know. I didn't come up with these words, obviously. All right. If I start on the outside, that was like when Charlie was holding the vertex, and we move towards the middle with those lines. Is that angle getting narrower or wider as we move towards the middle? We talked about it as if we went from the middle to the outside. That got narrower. What if I started on the outside and went to the middle? So if I was standing here looking at those people, as I walk forward, it's going to get wider. Okay? So if I start with the angle and I'm looking for the arc, I'm going to do a multiply by 2. But I can also do the opposite. If I know the arc, how can I go backwards? Divide by 2. So we're going to be looking at like what are we given and where are we going for these types of problems. All right, so here we go with our first example. We're on number 2 here. It's confusing because they're numbered weird. Picture 2. All right, on picture 2, what is the inscribed angle? H, G, and then J. And we know that that inscribed angle is 20 degrees. So if I want to find the arc, HJ, what that's saying is if I moved that outside vertex to the middle, so I'm moving it closer, what's that angle going to be? So as I move closer, is that angle going to get bigger or smaller? If I push it closer, bigger. So if it's getting bigger, should we multiply by 2 or divide by 2? Yeah, to make it bigger, we're going to multiply by 2. Another way to look at this is we're given the angle. So to find the arc, we're starting here, we're going this way, so we are going to multiply by 2. It's going to be doubled. So we're going to do 20 times 2. That's simple enough. What is 20 times 2? 40. Isn't that what you said? Yeah, you got it. So the measure of the arc, HJ, is 40 degrees. How much is the measure from G to H? That would be the angle HGJ is 20 degrees. If I want to know this arc, what I know from half, this is 40, so how would I find the other part? How much is... 180, yep. So we're going to do 180 minus... How much of the semicircle is taken up? 40 degrees. So what's 180 minus 40? 140. All right, going on to picture number 3. We are cruising. You guys, this took so long last period when we were like cutting and gluing and cutting and gluing. Nuts. You're gonna have time to actually work and get your work done. All right, so for number 3, how many inscribed angles do we have here? There's 2. What's one of them? We would do D to B. Okay, D to B, and then to A. So we have an angle DBA. And what's the other angle? DCA. Both of those angles, what's the arc that it intersects? Like if you look at the endpoints of the angle, what closes those endpoints? D to A. So they have the same intercepted arc. So let's think about that. If I have the same intercepted arc, if I know that this is 60 degrees, and I pull that back, so that means I'm going to divide by 2 for the pink angle. What's 60 divided by 2? 60 divided by 2. 30. Okay, but now if I do the yellow angle, it's the same thing. I'm taking that central angle and pulling it back. So 60 divided by 2, 30. So they're both going to end up being 30. We don't even need to know dA to know that those are congruent. So we're going to kind of write out our theorem here, because arc dA intercepts both angle, we said DBA, that's the pink one, and angle DCA. So DA connects the endpoints for the angles DBA and angle DCA. We know that those angles are the same. And what word do we use in geometry when things are the same? Congruent. So angle DBA is congruent to angle DCA. So they are the same. All right, so we're going to do one example with these. I think this is a goofy example. I just don't really math we would even use these, but we're doing it just for funsies because we can. The name of the book was like, we can do this, so let's do it. And I'm like, okay, thanks. All right, so for this one, what are our 2 angles? Say it again. Sorry, JHK. What did you say, Rama? Okay, so JHK is one angle, and JGK is our other angle. Do those open up to the same arc? What is that intercepted arc? Or what's across from those angles as they open up? J to K. Yep. It's kind of like a slice of pie. It's like we're taking it out and then we're going over, going over. So we don't even need to know what this side is here. we know that because they both have that JK, that means that they are congruent, which means that they are, what's another word for congruent? Equal, or they're the same. So we know that the measure of JHK is going to be the same as the other measure, JGK. And what is the measure of JHK, the yellow angle? What do they have it labeled as? X equals, what's the measure of angle JGK, the pink angle? 2x minus 54. The reason they're in parentheses is just to let us know that it's not just 54 degrees. We're doing that whole thing and then doing degrees. We're just going to practice solving for x real quick. So to get x by itself, I see we have variables on both sides. So we're going to get rid of this x. We could get rid of this one, but then we have 0, and then it just turns into a whole thing. So to get rid of a positive 2x, we would subtract 2x. How many x's is it on top when it's just x? 1. So when we subtract, we can think 1 minus 2. What is 1 minus 2? Negative 1. So negative 1x equals, the 2x is gone, so what am I left over with? Negative 54. And then our last step would be to undo that multiplying by negative 1, divide by negative 1. So x equals positive 54. Alright, I didn't put any like that in the practice work today. I just did it because the book says that we're supposed to do it, and I just think it's silly. But that's me. Alright, we're going to go on to the last two examples, 5 and 6. If you need to write any of that down, let me know. If you didn't, we are going to need some space for each. Alright, number 5. The information that we are given. I'm writing that word given because sometimes when we look back at our notes, we're like, how the heck did we get that? We didn't have to get it. It was given to us. Alright, in this one, we know that UW is a diameter. So it goes through the center, and it goes edge to edge. We also know that the measure of the arc from U to V. So try your best to make that U and a little separate. Is 68 degrees. I'll zoom in just a second here. And the measure of angle UVX is 46 degrees. Nope, 44 degrees. We're on number 5. What? Oh, I thought you were talking to me. Not talking to me. So UW is a diameter. We know UV is 44 degrees. So let's mark that on here, that this is 44 degrees. Nope. Who wrote 44? You guys. It's not right. UV is how much? 68. 68 degrees. Alright, there is a couple of things that I want to find. One thing that I want to find is the measure of VUW. VUW. Why is this just always crooked? And we want to find the measure of angle WVX. Alright, so we knew that UV is 68 degrees. Is there an inscribed angle that uses U and V as like endpoints? I'd go U something V. UWV is going to be that inscribed angle. So 68 is when we have that central angle, it's in the middle. But we're going to pull that angle back to the side. So as we pull it back, are we going to multiply by 2 or divide by 2? To make it smaller, when you pull it back, we divide by 2. Sorry, there was a goose running in the parking lot. 68 divided by 2. As we pull it back, the outside is 68 when we're in that middle. And then we pull it back, so we divide by 2. Anyone know 68 divided by 2 off the bat? 34. So we know angle W here is 34 degrees. And sneak that in there. 34. Okay, what about UVW opens up to UW. And we knew that UW, close. You're one step too far yet. Trying to work too far ahead. UW is what on the circle? A diameter. So diameter cuts it into what degree? 180. So I know UW, that arc, is 180. And to go from the arc to the angle, we're pulling it back, so we're making it smaller. So we're going to divide by 2. What is 180 divided by 2? 90. So I know at angle V here, this is going to end up being a 90-degree angle, if you can draw that box. Alright. What shape did we kind of highlight here? A triangle. We know that one angle of a triangle is 34. One angle is 90. What do we know all the angles have to add up to? 180. So close. Save it for the next problem. 180 for a triangle. So to find this angle, VUW. VUW is this last angle here. I'm going to, in the triangle, take 180, the whole triangle. And how am I going to find that missing amount? Good, we could add, not 68 though, 34 and 90. Or I can just subtract each of them. You could add them and then subtract, or you can subtract each at the same time. One. 56. Me too. So I know that last angle is 56 degrees. So that is VUW is 56 degrees. So when you see these shapes, inscribed in the circle, you're going to usually find other angles before finding the angle you are looking for. Okay? All right, last one is WVX in this one. So WVX is part of that 90. We know WVX is how much? UVX. How much is UVX? 44. I told us right here. UVX is 44. So if I know it makes a 90-degree angle, and I have 44, I need to figure out what does that other amount so that together they make 90. So subtract 90 minus 44. 46. All right, I know these are kind of long notes. You guys are crushing this right now. We have one more example. All right, number 6. We're going to be given some information with number 6 as well. What? It's open. Sorry, another one. It's open. Perfect. Got it. I understand. In number 6, we're given that the measure of JIL, of that arc, JIL, and it's an arc. We see that with that arc shape. Is and the measure of angle IJK. IJK is 139 degrees. I want to find what is JIL, angle, and the angle of ILK. Alright, so I would start by labeling our picture. So first we have JIL. Is that the arc or the angle that was given to us? For JIL, it's the arc. So we're looking on the outside of the circle. So J to I to L. That whole amount around is 154 degrees. We also know that IJK is 139 degrees. This is not a very well drawn picture. IJK. You guys, this is not right. I'm sorry, cross that out. I looked at the wrong thing. 41 degrees. My bad. You guys are going to see that 139 later. Gave you an answer. Alright, so that's 41. My bad. So IJK is 41. So we're going to put 41 here. Alright, if I look at that arc, JIL, I have J as one endpoint and L as another. So if I look at that angle that's created by those endpoints, if I start at the arc and I go to the angle, I'm pulling it further away. Am I going to multiply by 2 or divide by 2? Divide. So 154 divided by 2. 77. So this angle is 77 degrees. JKL. Is that one of the ones we were trying to find, though? No, useless. Just kidding, it's going to help later. Alright, I know JIL is 154. How could I figure out the other part of the circle? How much is the whole circle in degrees? 360. So if I do 360 and I take away that 154. Maybe. It's back there. Sure. $206. So that's this pink, that side. But if I find that angle, I'm going to take that and divide by 2. And 206 divided by 2, 103. Alright, that was one of the angles we wanted. That's JIL. Alright, we have one more we have to find, and that's the other angle inside that four-sided shape. What do we call four-sided shapes? Starts with Q, ends in quadrilateral, and quadrilaterals always add up to how much? Remember, triangles are 180. What's a quadrilateral? 360. Yeah, 360. So we need these four angles to add up to 360. So we're going to take 360 and subtract each of those angles. So minus 41, minus 77, minus 103. Jackie's our calculator lady today. Let me get 139, which is that answer I gave you earlier when I told you to write that number down and then we erased it. Perfect. Woo boy!